The rebuild of the crashed Bugatti Chiron quickly turned into something far bigger than a normal repair project. What started as a heavily damaged hypercar sitting in a workshop slowly became one of the most talked about rebuilds on YouTube, mainly because of how impossible the task looked from the beginning. The car arrived with severe front-end damage, twisted aluminum structure, deployed airbags, broken cooling systems, and missing parts that most people believe could only be replaced through official factory channels. According to statements surrounding the repair process, this was not the kind of car that should have been rebuilt in a normal garage. Hypercars like the Chiron are designed with extremely advanced engineering, complex electronics, and special manufacturing methods that very few workshops in the world can properly handle. That is exactly why so many people became fascinated when Matt Armstrong and his team decided they would attempt something most owners would never even consider. Instead of accepting that the car was beyond saving, they treated it like a challenge. The project instantly became more than just repairing damage. It became a test of whether modern hypercars are truly impossible to repair outside official factory systems, or whether skilled fabricators and independent builders can achieve results manufacturers claim only they can provide. From the beginning, viewers could already sense a tension between factory exclusivity and independent engineering skill, and that tension became the heart of the entire story. Every episode pushed the project closer toward proving that knowledge, patience, and fabrication ability could sometimes replace expensive manufacturer support systems that many people assume are absolutely necessary for cars. At this level point, one of the most impressive parts of the rebuild was a damaged chassis repair, because this was the area many people believed would completely stop the project. The front aluminum structure of the Bugatti Chiron had been heavily twisted during the crash, leaving major deformation around critical mounting points and structural sections that normally require extremely specialized repair methods. In many cases, manufacturers recommend complete replacement of these sections rather than attempting repairs, especially when dealing with high-speed impact damage on a multi-million-dollar hypercar. But instead of giving up or searching for impossible-to-find replacement pieces, the team approached the damage with careful fabrication work and engineering logic. Bob, whose fabrication experience became one of the most important parts of the entire build, slowly began cutting away damaged metal while preserving anything that could still be saved. Every section had to be measured repeatedly because even small alignment errors could create huge problems later once suspension, cooling systems, and body panels were reinstalled. The process was not rushed. Twisted aluminum was slowly heated and reshaped. Damaged welds were carefully removed, and new sections were fabricated piece by piece until the structure slowly began returning to its original form. What made the stage so fascinating to viewers was how normal the workshop looked compared to the image people usually have in their minds when thinking about hypercar repairs. There were no massive factory robots or secret manufacturer-only tools. Instead, viewers watched experienced hands, welding equipment, measuring tools, and fabrication knowledge solving problems that many believed only the factory could handle. As the rebuilt chassis section slowly came together, the project started changing from a risky internet experiment into a real demonstration of how powerful independent engineering skill can be when combined with patience and determination. As the structural repairs continued, the rebuild started gaining even more attention because the team was not simply restoring the car back to factory condition. They were transforming it into something unique. Once the damaged areas were repaired and major components were removed, the focus shifted toward the interior of the Bugatti Chiron, and this is where the project began looking less like a normal rebuild and more like a one-of-one custom hypercar. The original interior had a darker factory appearance with additional luxury materials, but the team decided to completely redesign the cabin using a bold purple and white theme combined with bronze accents. Watching the interior transformation became one of the most visually satisfying parts of the entire series, because viewers could finally see the damaged car turning into something beautiful again, instead of simply watching broken parts being repaired. Custom leather sections were carefully designed, patterns were digitally created, and detailed stitching work slowly gave the cabin a completely different personality. Every panel, seat section, and trim piece required precision, because hypercar interiors are extremely complex, with very tight tolerances and expensive materials that leave little room for mistakes. The rebuild team worked carefully to preserve the high-end feel of the original vehicle, while still creating a design that looked more personal and dramatic than the stock version. What made this stage especially interesting was how much confidence the builders showed while changing such an exclusive vehicle. Most owners of rare hypercars are afraid to modify anything because originality often affects value. But this project approached the Chiron almost like an artistic canvas rather than a museum piece. Slowly, the damaged vehicle stopped looking like a crashed car rescued from an auction and started looking like a custom-built hypercar designed specifically for this rebuild story. That visual transformation helped the audience emotionally reconnect with the car because it no longer represented destruction and failure. Instead, it represented creativity, recovery, and the idea that even something extremely damaged can become extraordinary again through vision and skilled craftsmanship. Another major turning point in the rebuild came when the team started investigating the internal components of the Bugatti Chiron, especially the safety systems. This part of the story became controversial because it challenged a lot of assumptions people had about ultra-expensive hypercars. When the damaged dashboard and airbag systems were removed, the team discovered part numbers and manufacturer markings that linked some components back to large automotive groups rather than exclusive Bugatti-only systems. This discovery immediately changed the direction of the conversation around the car. Instead of just being a rebuild project, it started raising questions about how much a hypercar is actually unique versus how much is shared technology adapted from other vehicles. One of the most discussed findings was the airbag module, which appeared to have similarities with components used in other mass-produced vehicles within the Volkswagen Group ecosystem. This did not mean the car was cheap or poorly engineered, but it suggested that even the most advanced hypercars often rely on shared industrial systems beneath their luxury branding. The team carefully tested and compared parts, sometimes ordering similar components from other vehicles to see how closely they matched in size, connectors, and mounting design. In some cases, the parts appeared to align surprisingly well, which added more curiosity to the build. This stage of the project did not just focus on repair anymore. It shifted into investigation, where every removed component became a clue in understanding how complex modern automotive manufacturing really is. Instead of weakening the reputation of the car, this process actually highlighted how global and interconnected the automotive industry has become, where even the most exclusive vehicles may still rely on shared engineering platforms, supplier networks, and standardized safety systems. It also reinforced a key idea of the entire project, that repairing a hypercar is not only about replacing broken parts, but also understanding how those parts were originally designed, sourced, and integrated into the vehicle in the first place as the rebuild moved forward. The cooling system became another serious challenge that tested how far the independent workshop approach could go on a vehicle like the Bugatti Chiron. After the crash, the radiators and cooling components were heavily damaged, and in a factory setting, these parts would normally be replaced through official supply chains. However, the team chose a different path and began reconstructing the cooling system using a mix of source cores, fabricated brackets, and custom-made fittings. This stage was extremely important because hypercars rely heavily on perfect temperature control, especially when dealing with powerful quad-turbocharged engines that generate extreme heat under load. Even a small cooling failure could prevent the car from running safely, which made this part of the project both critical and risky. Instead of waiting for manufacturer-specific replacements, Bob and the fabrication team carefully measured the original layout and began rebuilding the system from the ground up. They selected radiator cores with matching dimensions and flow characteristics, then designed and machined new mounting points so everything could fit properly within the Chiron's tight engine bay. Every hose connection, bracket position, and sealing point had to be adjusted manually because nothing was arriving as a complete factory assembly. When the system was first pressurized, it actually held for a moment, which was a major achievement considering the amount of damage the car originally had. However, a small leak later appeared during testing, reminding everyone that even successful fabrication work still needs refinement and troubleshooting. Despite this setback, the cooling system rebuild proved something very important. With enough skill and patience, even highly complex automotive systems can be reconstructed outside of official factory environments. This did not mean the process was easy or perfect, but it demonstrated that engineering problems can often be solved in multiple ways, not just a method originally intended by the manufacturer as the project approached its final stages. Everything began coming together inside the Bugatti Chiron, and the car started to feel complete again for the first time since the crash. The chassis had been repaired, the interior was fully redesigned, and the cooling system was functional after testing and adjustments. Electrical systems were reconnected step by step, and components that were previously damaged or missing had either been rebuilt or sourced through compatible alternatives. At this stage, the car was no longer just a repair project sitting in pieces. It was becoming a fully assembled machine again, ready to be tested as a whole system. One of the most satisfying parts of this phase was seeing how all the separate efforts finally merged into a single functioning vehicle. The custom purple and white interior now looked fully installed, with seats, dashboard, steering wheel, and trim all aligned properly and secured in place. Even small details like seat belts, switches, and finishing panels were carefully reinstalled, so the cabin felt complete rather than unfinished or temporary. Outside the car, the rebuilt bodywork gave it a strong presence again, no longer resembling a crashed auction vehicle, but instead looking like a finished hypercar with a unique identity. This stage also highlighted how many different skills were required to bring the project to life. Fabrication, electrical work, mechanical rebuilding, interior design, and system testing all had to come together perfectly for the car to function again. It was no longer just one person's project, but a coordinated effort between multiple specialists working toward the same goal. As the final checks began, there was a clear sense that the project had moved beyond the question of can it be rebuilt and into how well will it perform when it finally runs. The car was now prepared for its most important moment, the first full startup after being completely rebuilt from a heavily damaged state. The final testing phase of the Bugatti Chiron rebuild became the moment everyone had been waiting for, because it was the first time the entire system would be judged as a complete machine rather than separate repaired sections. With the chassis repaired, interior fully installed, and cooling system already tested under pressure, the focus shifted toward making sure the car could actually start, idle, and handle basic running conditions without failure. This stage was extremely sensitive because even a small mistake in wiring, fuel delivery, or cooling balance could prevent the engine from running properly or cause serious damage. The team carefully went through each system step by step, checking connection sensors and fluid levels before attempting ignition. When the startup process began, there was a noticeable tension in the workshop because this was a true test of all the fabrication work, sourcing decisions, and rebuild effort that had gone into the project. After everything was double-checked, the engine finally came to life, marking a major milestone in the entire rebuild journey. Hearing the engine run again confirmed that the core mechanical heart of the car was still functional despite the severe crash damage it had originally suffered. However, running the engine was only the beginning, as the team still needed to monitor temperatures, check for leaks, and ensure that all systems were stable under idle conditions. Even small fluctuations were closely observed because hypercars operate within very precise engineering limits. What made this moment especially powerful was not just the technical success, but the symbolic meaning behind it. A car that was once considered nearly impossible to repair had now been brought back to life through independent effort, fabrication skill, and persistence. It showed that even highly advanced machines are not always beyond recovery if the right knowledge and patience are applied. As the engine settled into a stable idle, the project transitioned from a rebuild challenge into a running, functional hypercar once again, proving that the entire journey had reached a point many thought would never be possible outside a factory environment. With the engine now running, the attention shifted to stability testing, because bringing the Bugatti Chiron back to life was only half the challenge. The real question was whether it could survive continuous operation without failure. The team began carefully monitoring temperature readings, coolant flow, oil pressure, and electrical signals while the engine idled. In hypercars like this, everything is tightly controlled, and even a small imbalance can quickly turn into a serious problem. The earlier repair work on the cooling system was now under real pressure, and this was the first time it had performed under actual running conditions instead of static testing. For a few moments, everything seemed stable, and the car behaved as expected, which was a huge relief after weeks of fabrication and uncertainty. However, the system was still not perfect. A minor leak detected earlier in the radiator section reminded everyone that independent rebuilds often require repeated refinement before they reach factory-level reliability. Even so, the fact that the engine was running and temperatures were holding within a usable range was a major success in itself. At this point, The project had clearly moved beyond the idea of a simple repair job. It had become a full reconstruction of one of the most complex performance machines in the world, using a combination of engineering knowledge, custom fabrication, and adapted components. What stood out most was how many different systems had to work together perfectly for the car to function even at idle. The engine, cooling, electronics, and structural integrity were all interdependent, meaning a weakness in one area could affect everything else. Despite these challenges, the rebuild continued to prove that even extremely advanced automotive systems can be restored when enough time, skill, and problem-solving effort are applied. As the testing continued, the Chiron was no longer just a damaged supercar brought back on the edge. It was now a running, evolving example of how far independent engineering can push the limits of what is considered possible. As the testing phase continued, the focus gradually shifted from whether the Bugatti Chiron could run to how complete the overall rebuild actually was under real-world conditions. With the engine idling steadily and temperatures mostly under control, the team began evaluating smaller, but equally important systems that determine whether a hypercar is truly road-ready. This included steering response, electrical stability, sensor feedback,